All right, we have one more major rules for derivatives. And the last rule for derivatives is called chain rule. And I forget what section number is this. 2.4. And we talked a little bit about the chain rule the other day in the context of this. Let's say I gave you f of x is 3x minus 5 squared, and I wanted you to take the derivative. Well, right now, today, you can do that. And how would you do that? Right now, in order to take the derivative, we don't know the chain rule. So in order to take the derivative, we'd have to FOIL that thing out and take the derivative. So if we FOIL it out, we'd have 9x squared minus 30x plus 25. I think that's what you get when you FOIL that thing out. And then we can take the derivative. The derivative happens to be 18x minus 30. Yes? You could also use the product rule. Very good. You could write f of x is 3x minus 5 and 3x minus 5. And then you could use the product rule. Well, let's see if we get the same answer. We better get the same answer or somebody screwed up somewhere, right? F prime of x is. All right, you got to remind me how the product rule works. I find the derivative of one and leave the other one alone. Okay, I'm going to find the derivative of the first one, that's 3. And then I'm going to leave the second one alone, 3x minus 5. And then add. And then you switch the order, right? So this time I leave the first one alone, that's 3x minus 5. True, in this case, it doesn't matter which one you leave alone and which one you take the derivative of, because they are exactly the same. But we'll do it by the rules anyway to make sure we understand the rules. All right, so we can distribute, clean this up. 9x minus 15 plus 9x minus 15. And the good news is we get exactly the same answer, 18x minus 30. All right, so what's the chain rule about? Well, the chain rule is about this. I'm going to give you a slightly different problem, but then I'm going to go back up and explore that one a little more. What if I gave you g of x is 3x minus 5 to the 20? The exact same problem. All I did is add a tiny little 0 right there. 0 shouldn't change anything, right? But it certainly doesn't this problem. So, could you FOIL that thing out 20 times? Well, in theory, we could, correct? How confident are you that you would not make at least one mistake somewhere along the way? Almost 0%, I would agree. We could also write that thing out 20 times and take the derivative by leaving the first one alone, or take the derivative of the first one, leave the other 19 alone. And then do that 19 more times. Work. We'd get the right answer. But now what we want to do is all right, so what I want to go back up here is and look at g of x, so look at f of x for just a second, and I'll show you where the chain rule is coming up from. What you're very tempted to do when you take the derivative, you're very tempted to take this exponent and bring it down front and subtract 1 from your power. You're very tempted to use the power rule. Unfortunately, that's not the right answer though, is it? Because that would only be 6x minus 10. Need to have 18x minus 30. How do I take 6x minus 10 and turn it into 18x minus 30? Multiply by 3. And 3 is something very special in this problem. What's 3? It happens to be the derivative of what's inside the parentheses. And that's exactly what the chain rule does for us. So, without writing down the chain rule, I'm just going to use it. G prime of x is, what the chain rule tells you to do, use the power rule like you've always used the power rule. Use it like you like it. So you bring the power down. You bring down to 20. You write down 3x minus 5. You subtract 1 from your exponent, 19. So there's the power rule. But then the chain rule says do one more thing. Multiply by the derivative of what's inside. What's the derivative of what's inside? 3. There's the answer. There's the derivative. It's all you have to do, which is much, much, much easier than foiling it out 20 times. And the derivative looks nice. It's fairly simplified already, too. All right, so we would probably write our final answer. I mean, I would probably do this. 60 times 3x minus 5 to the 19. Just multiply the 3 and the 20. All right, so now let me write down what the chain rule formally says. So this is the chain rule. It says if h of x is a composition of functions. So if h of x is f of g of x, then h prime of x is, you take the derivative of the outside thing. In this case, which function is outside, f or g? F. So you take the derivative of the outside, so that's f prime, but you leave the inside alone. Derivative of the outside, but leave the inside alone. But then the chain rule step says multiply by the derivative of the inside. So I'm going to write that in words. Take derivative of outside, leave inside alone, and then multiply by derivative of inside. That's the chain rule written in words. Written in symbols, it looks like that up there. All right, so now we're just going to take derivatives of a whole bunch of things. H of x is the square root of x squared minus 5. The first thing you need to start doing is you need to recognize when you need the chain rule, when you need the product rule, when you need the quotient rule. What in this problem tells me that I'm going to need the chain rule? Not only the square root of the x squared. More importantly, I'm going to write this way. X squared minus 5 to the 1/2. Good. All right, so anytime we see a square root, we get rid of the square root. Now, what tells me I need the chain rule is I see that I have a power, but the thing inside my power is not just the letter x. So when do I not need the chain rule? When I just have x to the 1/2. If I have anything else at all raised to the 1/2, then I need the chain rule. Or anything at all raised to any power would be chain rule. H prime of x would be, what's the derivative? Well, the thing on the outside is the 1/2 power. So I take the derivative of the 1/2 power. So I bring the 1/2 down and I subtract 1 from my exponent. What happens to what's inside the brackets? Nothing, it stays the same. So the x squared minus 5 doesn't change. So what's inside your brackets is not going to change. And that's one of the biggest mistakes I'll see people make. They'll take the derivative of what's inside the brackets. So you don't do that yet. Then you multiply by, what do I need to multiply by? Why do I need to multiply by 2x? That's the derivative of the inside. That's where that goes. Okay? So your parenthesis things are always going to stay the same. The derivative is going to occur out here. And that's probably the biggest mistake people will make is they'll put 2x in there and not have the 2x out here. Questions about that? F of x equals 18 over x squared minus 6. X. Let's put an x on the end there just for the fun of it. 18 over x squared minus 6x. How do I find the derivative? I could use the quotient rule. Excellent. I could use the quotient rule. F prime of x is. What tells you to use the quotient rule? It's a fraction. Anytime you see a fraction, that's a pretty good hint that you could use the quotient rule. Quotient rule starts with, leave the bottom alone, x squared minus 6x times 0, because the derivative of the top is just a number. Derivative of the top is 0. Minus the top, that's 18, over, 18 times 2x minus 6, that's the derivative of the bottom, divided by x squared minus 6x all squared. All right, so I'm just going to clean that up a little bit. I'm just going to write it as 18 times 2x minus 6. Oh, how about negative 18? Divided by x squared minus 6x squared. That's such a fun problem. I'm going to do it again. F of x is 18 over x squared minus 6x. Tell me a different way to do this problem. And if I move it up to the top, what's the penalty? A negative exponent. So this becomes 18 times x squared minus 6x to the negative 1. The whole thing, the whole denominator comes up to the top, and the whole denominator gets a negative 1 power. Now in order to take the derivative, what rule do I have to use? Now I have to use the chain rule, because I have a thing in parentheses with a power. Anytime you have a thing in parentheses with a power, that's a chain rule. So the derivative is f prime of x. The 18 stays right there. I bring the power down, that's negative 1. I subtract 1 from my power. Inside my parentheses, x squared minus 6x. Not quite done yet. What's left to do? Derivative of the inside, 2x minus 6. Is that the same answer I got a minute ago? Yeah, it's exactly the same, because this negative 2 power would tell me to put that on bottom. If I put that on bottom, it's exactly what I had. So you might remember the other day when we first talked about the quotient rule, there were some people grumbling that the quotient rule was difficult to remember. You had to do things in the right order. You never need to use the quotient rule. You can always use the chain rule and the product rule. So let me give you another example. About g of x is x squared plus 3 over x squared minus 5. You have two choices. Choice number 1, look at that, recognize it's a fraction. I can go ahead and I can use the quotient rule. So I'm going to do it that way first. G prime of x is bottom, x squared minus 5, times the derivative of the top, 2x, minus the top, x squared plus 3, times derivative of the bottom is 2x, all over x squared minus 5, all squared, bottom squared. And I'm going to go ahead and I'm going to clean that up, just because it's not too hard here. This is 2x cubed minus 10x minus 2x cubed minus 6x, all over x squared minus 5 squared. And so I guess nice and cleaned up, I would write negative 16x over x squared minus 5 squared. My answer using the quotient rule and the quotient rule alone. Works fine, fairly simple to clean up and make it look pretty. Well, or as pretty as that fraction gets, I guess. Bless you. All right, now let's do the same problem, except this time we won't use the quotient rule. So x squared plus 3 over x squared minus 5. I can write this as x squared plus 3 times x squared minus 5 to the negative 1. So again, anytime I have a fraction, I can make the fraction go away by bringing my denominator up and just putting a negative power on it. But now I need to recognize that when I go to take the derivative, what do I need? What do I have to use? I have to use the product rule, because right here I see I have an x times an x, so I'm definitely going to need the product rule. And I also see that I have a parenthesis with a power on it. That tells me I need the chain rule. So that's kind of the penalty for avoiding the product rule. A penalty for avoiding the quotient rule is you need to use the product rule and chain rule. Is that a big penalty? All right, so our answer would be g prime of x is. I leave the first one alone, that's x squared plus 3. I take the derivative of the second one. The negative 1 comes down. My parentheses will now have a negative 2. Inside my parentheses does not change, that's x squared minus 5. And then I got to take the derivative of the inside, that's 2x. And a common mistake I'll see is people will stop right there. That's only the first part of the product rule. We still have to do the second part of the product rule, which says plus, leave the second one alone, x squared minus 5 to the negative 1 times the derivative of the first, which is 2x. Here, to me, is the big disadvantage of doing it this way. How do you simplify that mess with all those negative exponents now? All right, you don't have to because it's the right answer. That's correct. However, in the very, very near future, like section 3.1, not only will we need to find the derivative, but the very next step will be set the derivative equal to 0. When you set the derivative equal to 0, you find something known as critical numbers. This answer, I can set equal to 0 and I can solve. In fact, the answer is 0, because the only way a fraction can be 0 is if the top is 0. The only way the top can be 0 is if x is 0. How do I set that equal to 0 and solve that equation that I would have?
Very annoying.
It would be very annoying, I agree. Okay? So, do you have to use the quotient rule? No, you can always avoid the quotient rule. The penalty for avoiding the quotient rule is the answer you're going to get is going to be more complicated. The algebra you need to do in order to solve will be much more difficult. Yes?
So why did you add x squared minus 5 and
Right here?
Yeah.
All right, because this one was, I left the first one alone. I took the derivative of the second.
Oh, I thought you were doing
Plus,
chain.
well, I did have to do the chain rule, all right? So that's a little complicated here. So I left the first one alone, that's right here, and then I took the derivative of the second. To take the derivative of the second one, right there is the spot where I had to use chain rule. Right, because that was when I took the derivative of this thing, that had the parentheses with the negative exponent. So I have to use both rules. So here's the product rule. I leave the first one alone, take the derivative of the second. In order to do that, I had to use the chain rule. Plus, then I got to switch it. Now I left the second one alone, and I took the derivative of the first. Okay? So sometimes you have to use the chain rule connection with the product rule, or the chain rule in connection with the quotient rule. Those things can happen. Moral of the story is, you can avoid the quotient rule if you want. The price you will pay is you better have good algebra skills. Because you better be able to take this equation, set it equal to 0, and solve it. Can be done, but it's not easy. If you just use the quotient rule, the answers turn out to be much, much more simple to simplify. That seems redundant, doesn't it? Much more simple to simplify. Oh well.
Combining like pairs and stuff make this one simpler?
What's that?
Combining like pairs and stuff, or would it just make it?
Unfortunately, for this one here, there are no like terms because these have different powers. What you would really have to do, unfortunately, is you'd have to drop this back down to the bottom, drop that down to the bottom, and then you'd have two fractions, but they would not have a common denominator. So you'd have to get a common denominator and add the fractions together. The quotient rule gives you the common denominator right from the beginning and puts it all together for you. So, your choice. You can avoid the quotient rule all you want. Be prepared to do more algebra, whichever one you like better. Oh, let's see. Y is cosine of 6x. I want to know the derivative, dy dx. What do I have to do? All right, I know that the derivative of cosine x is negative sine x. But that only works when I only have just the simple little x there. Once I have something more complicated than x, such as 6x, that rule doesn't quite work, but it comes close. What do I have to do? I have to use the chain rule. The chain rule says, take the derivative of the outside thing. In this function, what's the outside thing? Cosine is the outside thing. What's the derivative of cosine? Negative sine. What do I do with the 6x? Leave it alone. But then I'm not done.
You're going to take the derivative of 6x.
I have to take the derivative of the inside. In this case, the inside thing is 6x. The derivative of 6x is 6. So the chain rule shows up not only when you have parentheses and powers, the chain rule is also going to show up whenever you have trig functions. And you don't have simply just the letter x. All right, so how about f of x is, let's see how good you guys have been memorizing your formulas. Cosecant of x squared minus 9. Who remembers the derivative of cosecant? Besides me. And did you remember it, or did you flip back and look it up? All right. You need to memorize this. The derivative of cosecant is negative cosecant cotangent. However, I don't just have x right here. I have x squared minus 9. So what's going to happen? I'm going to have negative cosecant cotangent, but what goes in the brackets? X squared minus 9. But I'm not done. Multiply by the derivative of the inside. Multiply by 2x. Questions on that one? Here's a fun one. G of x. I find them all fun. I guess that's redundant when I say here's a fun one. G of x is, how about tangent cubed of, I don't know, anybody got something they like? Square root of x, right. X was too easy. What do? Chain rule how many times? Chain rule twice, at least. All right? So I think what you got to do, I'm going to rewrite this way. The tangent cubed, that notation sometimes confuses people. I'm going to write this as tangent square root of x cubed. Those are the same thing. Okay? So what you have to notice is, first off, I have a parentheses and a power. So that right away tells me I need to use the chain rule. So I go to take the derivative. G prime of x is, I bring my 3 down, and I subtract 1 from my power. What goes inside the parentheses? Tangent of square root of x. But now I need to use the chain rule, and the chain rule says, what do I do next? Multiply by the derivative of the inside. So I'm just going to write a symbol for that for now. Derivative of tangent of square root of x. Because now I need to recognize I have tangent, but I don't just have x there. So in order to take the derivative of this inside, I've got tangent of something more complicated. What do I need to do? I need to use the chain rule again. And that happens sometimes. Sometimes the chain rule is nested several times inside itself. Sometimes you got to use it 2 or 3 or 4 times. Here's a good example of where we need to use it twice, I think. All right, so we're going to have 3 tangent square root of x all squared times. Now I got the derivative of tangent square root of x. The thing on the outside is tangent. What's the derivative of tangent? Close. Secant squared. Derivative of tangent of secant squared. So I'm going to have secant squared. What goes inside my parentheses? It stays the same, square root of x. And then finally, I've got to use the chain rule one more time. The chain rule now tells me I have to take the derivative of square root of x. What's the derivative of square root of x?
1/2 x.
Excellent. 1/2 x to the negative 1/2. You have to think of square root of x as x to the 1/2. Bring your power down, subtract 1 from your power. So there's an example of where I needed to use the chain rule twice. That was a nested chain rule problem. It could be worse. It could be nested so that you have to use the chain rule 3 or 4 times. Let's see, let's make up a problem where we have to do something really crazy. H of x is x squared times 2x minus 6 to the 8th divided by x plus 4 to the 7th. What do you see there?
Chain rule
And one more. And product rule. We have to use all 3 of them. What tells me I need chain rule? Where do I see chain rule? I see parentheses with a power. Parentheses, in fact, I see it twice. What tells me I need quotient rule? That one's obvious. It's fraction. Where do I see chain rule? I'm sorry, where do I see product rule? The top has x's times x's. So I think in this problem you need the product rule, the quotient rule, and the chain rule. You need all 3 of them. And that can happen. H prime of x is. All right, so this is a hard one to keep track of everything you've done. We start with the quotient rule. Quotient rule tells us bottom, x plus 4 to the 7, times derivative of the top. And now I see when I take the derivative of the top, I have multiplication there, which tells me I need product rule. Leave the first one alone, that's x squared. Second one is a parenthesis with a power. That's the chain rule. I bring the 8 down. 2x minus 6 to the 7. And then I have to multiply that by 2, which is the derivative of the inside. So I'm half done my product rule. I left the first one alone. I took the derivative of the second. So now I need to leave the second one alone. And I wish I'd have left myself more space here. 2x minus 6 to the 8th. And take the derivative of the first one. The derivative of the first one is 2x. All right, so now we need to remember where we were. What did we do so far? So far we left the bottom alone, took the derivative of the top. So now we still need to subtract. And now we need to leave the top alone. X squared times 2x minus 6 to the 8. And we take the derivative of the bottom. And to take the derivative of the bottom, we once again need the chain rule because we have a parenthesis with a power. So I bring the 7 down, x plus 4 to the 6. But the good news is this time the derivative of the inside happens to be 1. So I don't really need to write it down, but I will anyway, just to show that I used the chain rule. Divided by x plus 4 to the 7 squared, which would be x plus 4 to the 14. You multiply your powers. And I'm going to choose to leave that one just like that this time. I'm going to choose not to simplify.
Now, will you ever have us set like one of these equal to 0?
I would not envision me giving you one that complicated on a test. I would not envision that. I do think that, say, this problem would be a reasonable one to give on a test. Take the derivative, find the critical numbers, they're called. That's what happens when you set it equal to 0. Okay? But no, I would not envision anything that complicated. The algebra involved is just too much to deal with on a test. Good problem for Wolfram Alpha. Type it in and have it solved for you. It would do it quicker than you would. All right, questions on that?